But nice to meet you all. My name is Amanda Gilbert. I am a staff solutions engineer here at Confluent. So I work with customers in the Southeast and in the enterprise space to help them solve questions around their use cases and just different things that pop up for them. And something that I see personally come up a lot is autoscaling. How would we do it, and is it something we should do? So I thought maybe it would be good to have a discussion around that and just what some of the pitfalls are and things that you should look out for. I also brought along someone who should be a familiar face to you all if you went to the keynote today, and that's Julie Price, and she's a senior product manager here at Confluent, so she'll be jumping in at the end to give us some updates just about how Confluent is thinking about scaling, thinking about auto-scaling, and making these decisions on the back end too. So with that, let's get started. All right, so auto-scaling is something that is on the tip of everyone's tongue right now, especially cloud architects. People are trying to think through, how do I get my systems to be more lean and efficient? How do I get them to optimize their resources? And how do I plan for and account for any spikes in demand or any dips in demand, and therefore scale in demand with it? But in reality, it's really just a capacity planning tactic. So when you break it down to its bare bones, we're really just thinking about how we plan for capacity, and that's the way that we should be thinking about scaling Kafka as well. And we define capacity planning within software applications as the ability to allocate the correct amount of resources that are needed for our applications at the time that they need them. This could be done using tactics like scaling up or adding more capacity to our systems, scaling out, or adding additional buckets of capacity to our systems. But once we make those decisions, we'll also have to ask ourselves if we are using the resources that we've allocated effectively. And if we aren't, we might not actually be seeing the benefits of the scaling that was provided. So auto-scaling then is really just doing capacity planning on the fly. So increasing or decreasing demand as our resource needs change. And this can be policy-based, so we can look at a fleet of servers and make decisions around when to scale out or in, and then also adding additional resources on the fly based on different triggers. Also, a cooldown period is going to tell us how long we should wait between each of those scaling events. So once I scale up, how long should I wait to then scale back down? How long should I wait to make another decision to scale up and add more capacity? And most of our CSPs are going to have native approaches to auto-scaling. Kubernetes also has some native approaches, and there's really a lot of content out there on this in general. But I think it's important to talk about how it applies when we are talking about scaling Kafka, because in that case, it's not so simple as just adding or removing like compute resources, for instance. We have to think about some additional components as well. So when we look at a Kafka cluster, right, we're going to have the base component of our Kafka cluster, and then we're going to have some ancillary components like Kafka Connect, KSQL. We might have some producer and consumer applications. And each one of those things is going to have a need for capacity. We're going to talk about that often in terms of storage, memory, and CPU. But on top of that, there are some additional abstractions. So for instance, our Kafka topics are going to host their data in partitions, which are really storing in segments on disk. And then we also have workers in Connect that have tasks associated that allow us to do scalability based on the amount of load that's required on those tasks. And then KSQL DB servers will also have tasks associated as well. These additional abstraction layers add additional complexity when we're making scaling decisions. And so long story short, deciding how to scale Kafka is really not for the faint of heart, especially if you're trying to do it in an automated way. And you might be thinking to yourself, but Amanda, I'm running on Confluent Cloud. I don't have to think about brokers or storage or like any other terms that you just threw at me. That may be true, but I think it's really important that we get a baseline understanding of what's happening under the hood when we're making decisions, because it can affect how and when we scale. In Confluent Cloud, as you heard today in the keynote, the core engine makes a lot of these decisions for us. They decide whether it should be a scale out action or a scale up action. They also are making decisions on the fly to allow clusters to scale in place for certain cluster types. And they are doing things like blocking connections to make sure that the multi-tenant clusters are not seeing any noisy neighbors. This comes with a few key components that make it explicitly different than running just open source Apache Kafka or even Confluent platform. In Confluent Cloud, if you're running on a multi-tenant cluster, so that would be like a basic standard or enterprise cluster, you're gonna be allocated to one of these cells, which are effectively just a designation of a group of brokers, and that's where your workload's gonna be running. And this makes it so that they can make scaling decisions on the fly. So if you need more capacity than what's allocated to the current cell, then you'll be moved to a different cell that has more capacity. It also means that you are seeing a multi-cloud network and routing tier that blocks any connections that go above the connection limit so that there isn't any degraded performance on the back end at the cluster level. And finally, it also separates out storage into a completely separate layer so that that can scale on its own and compute can scale separately. If you want to learn more about Quora, I did include a QR code. I think they had one at the keynote earlier too, but this is just going to take you to a white paper that will teach you more about the inner workings of Quora. Oh, and I guess one last thing, there's also data balancing happen on the back end that is going to automatically move data around for you. So as you're adding additional capacity, aka adding additional brokers, your partitions will be moved so that they're evenly distributed across those brokers, so that you don't see any of the negative effects of having partition skew. Now, with all of that being said, there are a lot of things that are handled for you, but there are some things that aren't handled for you. And yes, it would be great if adding capacity always meant that you had more capacity for your system or your application, but that's not really the case. And I think it makes sense before we talk about the concept of autoscaling to go into some of those bottlenecks just so that you can avoid them. And the first one I wanted to talk about is going to be a number of partitions that you'll choose on your clusters. So when you designate a topic, you'll choose a number of partitions for that topic, and there's going to be throughput limitations on each of those partitions along with the cluster level. So if you have a cluster that's running with 2 CKUs, for instance, and you're seeing some amount of performance degradation at the throughput level, this could be constrained by the number of partitions you have on your topic and not the cluster capacity itself. In those cases, it's not going to help you necessarily to add additional CKUs because there are per partition limits as well. So in order to benchmark this, you should be measuring the throughput on a single production partition and then making decisions about how many partitions to have on a topic based on the number of throughput that you expect. To size it, you'll want to think about the max throughput that you're expecting so that when your application does scale to that level, you can handle that load. Do keep in mind that there are some trade-offs when it comes to increasing partitions. As you increase the number of partitions, you are going to see some end-to-end latency, so you'll want to think about that as well. And you don't want to do this in place. You really want to make these decisions up front because when you try to repartition in place and add additional partitions, although technically you can do it, it could lead to your data being out of order. So just be careful with that. And then you also can't downsize the number of partitions. So it really makes it not a great way to approach scaling or auto-scaling because it's dangerous to scale it up and you can't really scale it down in place. So the long and short of that is to make those decisions as early as possible and to be aware when you're changing anything when it comes to the number of partitions on your cluster. And then a quick point out that your partitioning strategy is going to matter here too. So if you have a partitioning strategy that's creating an uneven distribution of data across the partitions on the topic itself, then adding additional partitions might not solve your problem. So really make sure that you're dialing into your partitioning strategy and the number of partitions that you're creating. Okay, bottleneck number 2 would be producer and consumer configs, and I see this one a lot. Your client-side configurations could be the source of your problems when it comes to you not meeting your SLOs. The reason for this is that your producers are going to send data to Kafka in batches, and they're going to wait for a period of time to do that, and then your consumers are going to read that data off of your Kafka topics. You'll want to baseline with the Kafka performance tools to get a good idea of what you should expect to see across your entire cluster when it comes to throughput. But then you should also baseline your specific app's throughput to make sure that you don't have any bottleneck that's popping up there from a configuration you have set. And the metrics that you monitor are going to depend on your specific service goal, but you should be running these benchmarking tests and then altering your configurations and rerunning them to make sure that they are performant. If your clients are tuned correctly and the cluster is still overutilized, then you might want to look into a scaling event, but I would verify that your configs are aligned to your service goals first before you take that action. And then the third bottleneck that we'll dive a little deeper into today is client connections. And this one I think is important to call out because this is where I see people get tripped up the most actually, and not necessarily understand what's going on when their cluster is overutilized and try to just scale it to fix the problem and actually end up making the problem even worse. So what's happening when your client connects to the cluster is it's going to send an attempt. The cluster is going to either say, yes, it was a successful authentication, or no, it was an unsuccessful authentication. Each of those attempts, either successful or unsuccessful, are going to be registered as an attempt. And there's a fairly low limit on the number of attempts because they do utilize a pretty large amount of CPU on the underlying cluster and therefore put the cluster at risk. And then you're also going to have, once that attempt is verified, you're going to have a connection opened, but there's going to be a connection opened from the client-side application to each of the leader partitions that it's trying to read from. So in the case of a producer, if it's producing to a topic that has 6 partitions, let's say, and those 6 partitions have leaders that are spread across 6 different brokers on the back end, it's going to open up 6 connections there. So it's not necessarily one-to-one. And as you scale out and add additional capacity, really you're adding additional brokers on the back end, and that means that you could be opening up additional connections. So you should be measuring these pretty stringently and just ensuring that you understand what's going on. And you should also be monitoring your audit logs to make sure that there's not a rogue client that's acting in a bad manner and causing a large amount of connection attempts, because you could see those getting blocked in the future if there's a large number of them. The other thing that you'll see is you'll see some added latency as well. So once you get up into a large number of client connections, it is more of a soft limit in terms of the actual connections that are open and the requests that happen against the cluster. But you could see some added latency there, and so you'll want to account for that and monitor for it as well. All right, a couple other things you can do to remediate is have longer lived connections so that you have less connection attempts. And then just evaluate your application architecture, ensure that you have the right number of partitions, ensure that your client configurations are correct, so that you are not consistently opening up and sending requests to the cluster, right? So longer batches, less requests. Those are the things you'll be wanting to think for. Okay, a couple other ones that we are just not gonna have time to get into today that I think are worth diving into on your own time are things like partition imbalance. So we talked a little bit about the skew across different partitions in a single topic. But if you're running your own open source Apache Kafka, you also could have partition imbalance across the cluster. So partitions being unevenly distributed across your brokers. If you're on CC, you don't have to worry about this because that balancing is happening for you. But if you're not, then that's something you'll want to think about. And if you're on CP, you'll probably want to utilize something like self-balancing clusters to solve for this. And then on the client side, consumers can be scaled up to the number of partitions that are on your topic. So you'll want to add additional application instances there to be able to capitalize on consumer parallelism. Connectors, you're going to be limited by the number of tasks that you have and the amount of throughput that those tasks can manage. So you should be using capacity-based scaling there to make decisions around how many tasks your connectors should be running. And then your stream processing technologies are going to rely heavily on how optimized your topologies are. So in that case, before you just go scaling or up or down when it comes to the amount of capacity you're throwing at your stream processing resources. You'll also want to dig into those topologies and make sure that you don't have a bottleneck going on under the hood there. All right, so now we've talked about some of the things that you should try to avoid or at least account for before you make a sizing decision. And really the outstanding question is, once I've done that, is it one size fits all? Can I, Amanda, tell you guys how to auto-scale your cluster? Not necessarily, because scaling needs are driven by a few different things. First and foremost, they're driven by use case. So once everything is as it should be, you're gonna wanna look at what type of scaling use case you have. And we've separated this out into 3 different buckets. Predictable spikes for more major events, things like Black Friday, things that you know are coming, but they're gonna be a large increase in load on your system. Also predictable spikes for more minor events, so that could be things like a daily batch job that's running, something that happens every week, or even hourly spikes that happen throughout your day. And then the third bucket would be those unpredictable spikes. And this is really where the big gotcha is, right? Is that if you are not taking care of your cluster and accounting for any of these unpredictable spikes, you could run into problems here, and they could be very impactful to your business, right? Could cause you to not meet your SLOs. So these are the ones that you'll want to make sure you have good plans in place beforehand. All right, so when it comes to predictable spikes for major events, I want you to consider, for instance, that you are a retail business and you are planning for upcoming Black Friday. In terms of Black Friday, it's going to be a really predictable change in the amount of load that's put on your clusters. So we know that we're gonna see more transactions during that time. We know that we're gonna see more hits to our mobile and web applications. And we know that the demands of our customer are gonna be really, really high, right? They're not gonna accept any performance degradation on Black Friday. We've gotta be up and performing, or we might lose the business. In this case, you should be benchmarking your cluster and resources very tightly, understand where your different bottlenecks might be, and then scale test very heavily prior to the event. You also probably want to make sure that you are giving a little bit of headway, over provisioning a bit, just in case you didn't plan correctly for the amount of additional capacity you would need. You'll also want to ensure that your clients are properly configured and that you proactively scale depending on what you're expecting, but then in place, in time, as it's going on, that you're monitoring really strictly, and that you have a remediation plan if you did not correctly plan. The second case would be minor events. So now I want you to shift gears and imagine that you are a food delivery service, and that food delivery service has spikes throughout the day, usually at lunchtime and dinner time. This is predictable as well, but it's infrequent, and sometimes it can be less of a spike than something like, say, Black Friday, less of a major event. In case of predictable spikes for more minor events, you will still want to be benchmarking heavily, but you're probably at this point with where the product stands today gonna want to over provision for that type of use case, right? Doesn't necessarily make sense when it takes an hour to a few hours to add additional capacity to do that in place as it stands today. Julie will get into how that's changing in a bit here. And you also should choose the number of partitions on your topics based on your max throughput. Since this is something that occurs so frequently, you'll really want to account for it as if it is your standard. And then, of course, the last state, the state that is everyone's fear. Now I want you to imagine that you are a utility company and that you need to plan for some sort of weather event that could happen and come out of the blue. These unpredictable spikes, it's really like a range of unpredictability, right? They either could come out of nowhere, like a viral social media trend, something blows up on TikTok and now all of a sudden your servers are totally overloaded, or you could have some sort of information about them. But either way, in a best case scenario, you should be monitoring so that your administrators can make decisions about when to scale, so that they can ensure that that's really what's going on, that there really is that additional load before adding the additional capacity. And auto-scaling in this case should be more of a backup plan, not a one-stop shop. So once things really start to go off the rails, that's when you would want to consider putting something in place to catch those like off the rails type of use cases. And you'll also want to make sure that you put some natural bounds on that scaling process. You don't want this to be something where it just continues to add additional capacity just over and over again, right? You'll want to have a long cooldown period so that it has time to do the rebalance on the back end, and that you also set a cap on the amount of capacity that you add, right? Just so that your administrator can step in and make an informed decision. Alongside our use cases, though, there are a few other things that we should be thinking about when we are creating a capacity plan. So in terms of service goals, what are you actually trying to optimize for? What do you care about? And what are you going to be responsible for? So do you have internal or external SLOs that are specific to your use case or to your business? And what type of degradations can you handle? And for how long can you handle them? This will help you make decisions about how automated the process should be. And then you also should consider that there could be additional bottlenecks, as we talked about earlier, in different parts of your pipeline. So look at your whole entire pipeline when you're making those scaling plans. Where you can, you should lean on tools that support scalability, and we'll talk about what some of those are to make your life a little bit easier. Okay, so let's talk about implementing a capacity plan. If you walk away from this ready to do that, what would that actually look like? I'm kind of going to break it down into two parts, which would be a scaling plan. So what do you do to determine how you need to scale? And it's an end-to-end problem, so you really need to think end-to-end when you're coming up with a solution. And per use case, you should be thinking about your specific service goals and objectives, and then defining your capacity requirements from that. From there, you should be benchmarking your different components at baseline, and you really can't effectively auto-scale until you do this. So this should be the first thing that you do, right? Get an understanding of exactly how much each additional unit of capacity is going to bring you. From there, you can create a capacity plan based on benchmarks and different runbooks for different scaling scenarios. So for instance, I know that my Kafka Connect task here can handle 15 megabytes per second of throughput. So anytime that I start to approach that, I'm going to create a runbook to automatically scale that, that piece of my architecture, add additional tasks there, and then I can move on to the next piece, right? So having those really granular plans around scaling will be helpful for you when you actually hit those points of needing additional scale. And you should be automating where possible, but this doesn't really necessarily have to mean true auto-scaling. I think true auto-scaling would be like the nirvana state and gold standard that some organizations may be able to accomplish down the line, but you can get a lot of benefit from the in-between, right? You can get a lot of benefit from just writing out automated script, writing out runbooks, and having your admins know when to kick off which of those scripts. Secondarily, though, you'll need to create a maintenance plan. So outside of just what happens when we want to scale specific pieces, you'll also want to be monitoring your pipeline very strictly, and that's both server side and also client side. And also scale testing before any known scaling events or unknown scaling events as well, right? Just testing the pressure of your system, seeing how it affects it. Another thing that you should be doing if you are an admin of a cluster and you are allowing other people to use that cluster is setting up client quotas. So if you're using a dedicated cluster, you can restrict the amount of throughput that different apps are able to utilize within that cluster space. So you should be doing that as well. And then we've talked about this already, but also protect against any bad actors by defining an access management strategy, and you can namespace your own cluster. So if you read a little bit about how Confluent Cloud works under the hood, in the multi-tenant capacity, there's a lot of namespacing going on there to split up and logically isolate different tenants. And you can do the same thing yourself by using prefixed access control lists and then setting your access policies. All right, so taking an example here, let's imagine that our data pipeline has a Kafka cluster that is a CC enterprise cluster, and that has a max throughput of 250 and 750 megabytes per second. That's write and read respectively. And then we have a single connector, and we've benchmarked that at 15 megabytes per second per task, a K-Streams application, and then a consumer app. And our service goals on this are that we're gonna have an average throughput of 10 megabytes per second write with 3x fan out, and then we're also gonna have peak throughputs of 50 and 150. We have a low tolerance for any degradation at peak. So what should we do? Well, we know our maintenance plan already, right? The different things that we need to do to keep this consistently running in a healthy fashion. But in terms of scaling, we don't need to think about our cluster if we're running on enterprise. We just need to make sure that the capacity stays below the upper limits of an enterprise cluster. And then Kafka Connect, we would want to automate capacity-based task scaling. So in this case, if we are seeing that it's getting up to that 15 megabytes per second mark, automatically kicking off and deploying a new task. If you're running Connect yourself, that means you'll also have to account for scaling the workers alongside with the number of tasks, so keep that in mind. In terms of Kafka streams and our consumers, there's actually a lot of good content out there on autoscaling. Someone did a talk at Kafka Summit London on autoscaling Kafka streams. I think it was this year, so I'd recommend going and looking into that. Because there's a lot of great content that exists. So you can think about using autoscaling when it comes to something like Kafka Streams or your consumer applications. And a quick note for platform teams, if you're a platform team that has internal teams consuming Kafka, then your scaling use case might be different than like just an on-demand, there's a predictable spike or an unpredictable spike. It could just be that you're onboarding more teams and you're starting to hit the capacity limits. So a couple of things you should be doing in terms of best practices. You should be implementing client quotas, but keep in mind that client quotas are going to be each time you give out, like, I need this client quota for this principal ID. If they were to use the API key associated with that service account 5 times, let's say, it'll apply to each of those 5 instances. So just keep that in mind. You'll also probably want to just implement some best practices and templated approaches to clients for your users because they might not know Kafka as well as you do, and you don't want them running into the bottlenecks that we discussed earlier. You should be proactively monitoring and auditing, especially if you have other teams using the technology. Make sure that they are doing what they're supposed to be doing on the cluster and nothing more than that. And then you can implement a set of automated scripts for scaling your clusters, Connect, et cetera. So if you have heard everything that I have to say and you still want to autoscale Confluent Cloud, where are the places that you could utilize something like that? I think it comes in really one main place when it comes to the cluster itself. There are a lot of opportunities for autoscaling if you're self-hosting things like Connect or Kafka Streams. When it comes to the cluster though, you have to keep in mind that it operates a little bit differently, right? When you're adding capacity, what's really happening behind the scenes is that Confluent is then going, provisioning additional brokers, and then moving around the workload. So what you want to be doing is first and foremost having a strategy to have an administrator correct the high amount of cluster load. But if it gets to that like deadly level, that 80%, then there are some other metrics that you can look at alongside cluster load to make a decision if you are going to autoscale or not. So that would be things like a high amount of consumer lag, or your consumers not being able to keep up with the rate of production, or a high producer buffer, meaning that your producers are not able to consume in time. And then an honorable mention would be connections and requests, but we talked a little bit earlier about why that might not be the greatest indicator every time. So if your cluster is dedicated and your ducks are in a row, really the main place that you could look at autoscaling here would be having a cluster load greater than 80%. You could set this threshold lower if you were a bit more cautious, because that 80% mark is where you're going to start to see things with additional latency. You're going to start to see connection attempts fail. So you might want to even set it a little bit before that. And you see one of two things, either a high producer buffer or a high or rapidly growing amount of consumer lag. If this happens, you should be scaling up aggressively, but you should be scaling down very conservatively. If you scale up and then it looks like the problem's addressed, so you scale back down, and then it's not actually addressed, you could be in for a world of hurt, and you're also putting a lot of load on your cluster doing that scale up and scale out. So just be careful there. And then as I mentioned earlier, don't forget a cooldown period. So make sure that you give the cluster enough time to adjust to the new capacity that it has. Okay, a couple other things. This is weird. It only showed a couple of the, one sec. All right, Lambda disappeared, that's fine. Some tools to consider. In the meantime, if you're thinking about implementing something like this, I would lean on some additional tools. So You're going to need to really get familiar with the CC APIs, so the metrics API and then the admin API. Those are going to be your go-to for pulling out metrics information and then also for performing actions on the cluster like resizing it. And then you'll also want to monitor JMX metrics on the client side. So this could be connected to like a monitoring tool like Datadog or something of the like, or you could just use the REST API. You could hit it directly. If you're self-hosting components, then you could look at Kubernetes, and then also I've seen a lot of content out there on people using Kita to do, like it's an event-driven autoscaler, so to do a little bit more intelligent autoscaling. And you could also even use Kafka for this, so putting actual events into Kafka to notify you of when to make scaling decisions or different remediation plans. Okay, with that, I'm going to bring Julie up on the stage to talk a little bit about what's coming. So, yeah, I think I'll switch.
Hey, everybody. So that was a lot of great information on all the various different components you need to look out for scaling. And if you attended the keynote this morning, you might have heard a couple of things. One, we run Kafka at scale. That's what Confluent is all about. Two, we want to make it really easy for you to scale. And three, we recognize that a lot of you are still going to continue to use open source Kafka. We believe in the project, we believe in the community, and we're going to continue to contribute there. And so I want to talk about a couple of things that are happening both in the open source community and here directly at Confluent that can help you with making decisions for scaling. And so if we look, we talked about the various different use cases for scaling, those predictable spikes, either something that is coming, it's a major event, or maybe a weekend spike or a certain time of day spike, and then finally those unpredictable spikes. So some of the things that I'll talk about will address each of those different scenarios and use cases. We do want to make it, we would love to be able to say that no matter what at any point in time, you don't have to think about it. We're not quite there yet, but we're getting closer. So the first thing is enterprise tier. As I talked about this morning, enterprise tier, it's GA now, so we have delivered it, and it really works nicely for all three of these scenarios, provided that your workload is under 1 gigabyte per second, or maxes out at 1 gigabyte per second, because that's currently the ceiling for enterprise. That will get bigger, and it'll probably get bigger fairly quickly, but right now that's what the ceiling is. And now, for the open source space, and really for any managed service that's running Kafka, one of the hardest things right now is that, Amanda mentioned a number of different things that you would want to monitor to make decisions about whether or not to scale. And right now you've got server-side metrics coming from one place and client-side metrics coming from another, and it's hard to actually monitor those together. There are some great tools out there. Amanda mentioned some of them that can bring them together, but we've got this KIP 714. So if you are really engaged in the Kafka community, you might be familiar with that number. What that is actually making those client-side metrics available to the server so that all of the metrics can be in one place. So now once that KIP comes out, we'll be able to utilize those, and we'll be able to give you the ability to monitor your metrics all together. So now you can create correlations between, hey, I'm seeing some type of throttling, or I'm seeing consumer lag. Is it really something that's going on the server side? Do I need to rebalance? Is there another decision that I need to make? Or, oh shoot, is it because of something that is getting bottlenecked on the client side of things? So that's going to be really nice, for the whole community. And then a couple of things that are specific to dedicated clusters, if any of you are using dedicated, and this will have impact on just the efficiency overall of the other cluster types too. But the first one is multi-CKU shrink. So CKU, hopefully that is a familiar term to you, but that's a Confluent unit for Kafka, essentially. It's how we define how large your clusters are. Currently, you can only shrink a cluster by 1 CKU. So if you've scaled up for a really big event, or if you have, a time of business hours type of scenario, and you need to scale up by a bunch of CKUs, when you go to scale down, you have to do one at a time and wait. And things have to happen in between each time that you issue that call you have to wait until that completes to be able to do the next one. And so we're going to deliver very soon, our next month, we will be delivering multi-CKU shrink that'll give you the ability to issue one command, and it will shrink the cluster. It'll happen much faster. So that really helps that if you, let's say you have a 9 to 5 type of business, and at 5 o'clock you want to shrink your cluster, and then you want to grow it again before that 9 o'clock traffic starts to come in, you'll be able to do that much more easily because the shrink will happen faster and you don't have to do it one at a time. It also helps with those predictable spikes for major events, because if you scale up really high for Black Friday or for the Super Bowl or some other reason, you can scale down a lot more easily. It's just a lot less toil for operators, which is nice. And then the last thing I want to talk about, something that we're really excited about, is faster scaling. So I'm the product manager that manages that space, and I get a lot of every time a cluster scaling action takes a long time, I end up, knowing about it, talking to the customer, trying to figure out what's going on. And so we're doing a lot of work to have a much faster scaling per CKU SLO so that you can support those types of scenarios, so that you can support a once-a-day scaling pattern. Previously, it was a little bit too variable to be able to do that, and so that'll be coming soon as well. So those are a couple of the things that are happening that I'm really excited about that will definitely help with those scaling scenarios. I'll call Amanda back up because now we have about 8 minutes for questions.